We are now going to start with the first technical session of the third day, which is the sixth technical session of the overall workshop on the topic Open Data Management, Role of Librarians by Dr. A.R.D. Prasad, who is the former professor and head of Indian Statistical Institute, ISI, Bangalore. He has an experience of around 40 years with 29 years of teaching and research in ISI. He was a member of DSpace Governance Advisory Board, Massachusetts Institute of Technology, MIT, USA. He has been hosting Ubuntu-based live DVD pre-configured with DSpace Koha on SourceForge, which is an open source directory. He has helped in setting up digital libraries for some IITs, NITs, CSIR, DRDO labs, universities. He has conducted more than 50 training workshops in India, Sri Lanka, Thailand, Tunisia on behalf of UNESCO, Samoa, Malaysia on behalf of Commonwealth of Learning. He has been a member of High-Level Committee, National Commission for Libraries, Government of India, a member of Working Group on Libraries, National Knowledge Commission of India, a member of Project Evaluation Committee on E-Infrastructure, European Commission, Brussels. He has been a consultant to UN FAO Rome and a consultant to UNESCO Paris. He has also been a consultant to Commonwealth of Learning, Vancouver, Canada. He has been a mentor to Google Summer of Code, Google Headquarters, USA, and has been a member of Electronic Theses and Dissertations Committee in FlipNet, Information Library Network of India, and a member of University Grants Commission, UGC, of India Curriculum Development Committee on Library and Information Science. He is a Fulbright Scholar, visited University of Maryland, College Park, Iowa State University, and has guided 13 PhDs and published 4 books and about 80 papers. He has also been a part of various projects like Living Knowledge, funded by European Commission, Area Semantic Web, Egg Infra, funded by European Commission, Area Agriculture Data, a project leader of India Trento Program for Advanced Research, Area Ontology, and NGO portal for UN AIDS Program for WHO India. Over to you, Prasad, sir.
Oh, thank you. I think, jokingly, I'm saying you are one of the very, very few people who could read my mind. There are many people I don't know. They fumble and halfway through they give up. Okay. So, anyhow, first I would like to thank Dr. Sri Kumar for inviting me to be with you and share my ideas. Some of them are very quirky. In the sense, I go a little offbeat and maybe aggressive in the subject. But again, my commitment to the subject, I think, is definitely not questionable. Okay. And I want to see that the library community is always on the forefront. Normally, I say that I don't have any communal feelings, but except the library science feeling is there a little. Okay. That way I am highly communal. Okay. So I think as Dr. Sri Kumar told that, I think about 60 of your participants. I don't know. See, I am doing this job on a third day. I am sure probably you might have got some hints from other speakers how the future of libraries or library science course curriculum would incorporate data-related topics in the library and information science curriculum. Actually, this year, DRTC is offering almost 2 or 3, 1 specialization also, 2 regular papers, and 1 optional on data-related stuff. So, but again, I am very clear about what exactly the librarian's role in the so-called data science. Because nowadays, big data, data science, all these are hyped up a lot. Okay, so just as when digital libraries came, I try to demystify digital libraries by simply running workshops on DSpace, which is much simpler. Okay, similarly, data too. See, librarians, to begin with, they were talking about books. Then Ranganathan came into the scene and said, no, they have to deal more than books. So let us use a comprehensive word where books are one of the constituent parts. So he said documents and documentation. I think he was, really carried away by that word, though I have my own reservations on that. Later, I think the worldwide we started calling A.R.D rather information science to it, because pure information science, computers and many people would raise their objections. So we started calling library and information science. So we are talking about information. Now we have to go further, as much of the information is fairly based on data. Okay, you know, much of the research is based on data. So thus far, the journals never bothered to publish the data, but now publishing the data is becoming slowly a commonplace, because some publishers are insisting, along with your paper, you should submit the data. Good old days, publishing data would be a big printing number of pages to print, but with web technology and storage becoming cheaper, it is much easier to publish online, including the data. I only hope publishing industry would not come back with a saying, no, no, unless you pay for that also, we don't share the data. But anyhow, I would try to focus on some of the issues that, you know, that at least some of you, okay, know that I try to advocate openness. Whether open research, nowadays everybody is talking open research and open science. But before that, we have open access to information and open standards. Many things are open now, which is better for the growth of the society. Openness is essential. Okay, unless of course one get involved in a research to build killing machines like missiles and other things. There, of course, the research won't be open, because every country believes only they should kill the efficient way. Others should not know how to kill other countries' people. Okay, yeah, I am a pacifist. I am against wars. Okay, that I will. I think soon in my talk you will realize I will be talking a lot about my personal opinions. Okay, now please help me. Whether you could you see my slide?
Yes, sir. Yes, sir. Please go ahead.
Yes, okay, sir. Thank you. Thank you very much. Okay, because in a regular class, I don't have to confirm whether you are watching this or not. Okay, of course, I have put Creative Commons license attribution, but I think I will remove that. I will put 0. Anybody can use this. I think. Okay, now, what are exactly the sources of data? Data comes from research laboratories, universities, even industrial R&D. Okay, if industries have R&D, we have data. And data from research projects, survey, we know that much of the social sciences people generate data from various surveys. Okay, mostly they are in tabular form. Okay. Whereas other subjects like, say, for example, I have friends in remote sensing and meteorology and oceanography. They get a lot of data from satellites. Okay, that's a different issue. Then we have a lot of streaming data from various equipment like sensors, then CCTV cameras and all that. You know, for traffic control also, we use a lot of CCTV cameras. And in fact, many people believe more data is generated by machines than humans. That is true. It is easier, satellites, CCTV cameras, then medical people use equipment to generate data. So various equipment in the laboratories, we generate data. And nowadays, the recent phenomena, recent means now, of course, more than 10 years, social media. Social media is generating huge amounts of data. Though if you look at probably on a Twitter or something like that, you may enter only a small paragraph, but together with lakhs and lakhs of people, together it makes a huge data. That's the reason they run clusters of computers to meet the data storage requirements and transmission also, okay, over the network. That we will come to. Just, I mean, I am giving somewhat old statistics. Facebook handles 30 plus petabytes of user-generated data. Okay, YouTube users upload 48 hours of video every minute. Staggering, no? That is. And Twitter gets about 175 million tweets every day, but this is old data. Then Google processes about 20,000 petabytes of information a day. Data from the net and social media is heavily used by business analytics. Now, of course, now you will see a little true colors of mine. Many of my computer science friends from the Europe, they get a lot of projects from business community. That is to cull out opinion mining from social media. So how to promote their products. For example, if you, the other day I think I was looking for a mattress, and even now I keep on getting advertisements from various companies who sell mattresses. That means somebody is watching what you are searching. So that is big data, obviously. Okay, so that data is, otherwise, do you think Google is a philanthropic organization to provide free service to you? Okay, in fact, we have a joke. For many software companies, you are a customer to sell their product, isn't it? Okay, they come to your office and try to impress. This is a powerful statistical package or library automation package. So for many companies, many software companies, you are a customer to sell their product. For Google, you are a product to them to sell it to everybody else. Okay, whoever is interested to know about you. That means they reduce it to you the product level, and thereby they generate a lot of income. Okay, so that's why some people say, "What is privacy?" I know in my ISI, when in DRTC we are using Google G Suite Mail. Okay, many people say, no, what is the privacy? Gmail fellows may. I said, hey, on internet, if you use internet, there is nothing called privacy. It is as good as standing stark naked in the middle of the road. Everybody can look at you and they can find out what you are doing. Okay, so it is a myth to believe that there is some privacy and nobody is looking. So actually, that's what I say. My philosophy is, business guys try to loot you, okay, whenever you are using internet, and governments do a lot of surveillance. Okay, every government. Okay, surveillance. This one, what people are doing, because I know that for some time I was on a review of some huge project. Their job is to find out whether there are any messages on terrorist messages. Okay, I mean, how to identify those messages and other things. But again, in the process, every government uses the name of the terrorist, but for them, every citizen is a terrorist. They can practically know everything about every citizen. Okay, bigger countries with developed equipment, developed internet, and all that, they do more monitoring than. That's why they say CIA knows what Merkel is, the German chancellor until recently. What Merkel is talking to her husband also, they would know. Okay, everything they know. Okay, whether you use WhatsApp, phone, mobiles, internet, everything, all these things. But again, all these things amounts to huge data. Now, how do you handle mammoth-sized data and get whatever you want? Okay. So if you look at data, we have structured data. This, I think, we have completely beaten track. Because on database management systems, whether it is bibliographic metadata and other things, these are all structured. That's why querying is easy. When it comes to unstructured, query becomes really, really complex. That is the reason we are talking about data mining, text mining, how to get some structural information out of unstructured data, means continuous text. Continuous text only humans can understand. then we are still, I think, making some inroads we have done, but still a long way to go how to mine data from various continuous texts or any body of knowledge or something like that. Then we have audiovisual data, we have streaming data. This is, of course, social media, your YouTube, everything are streaming. Okay. Now, so big data. What is big data? Big data is a broad term, okay, for data sets so large or complex that traditional data processing applications are inadequate. That means, you see, until now, of course, still it is, the relational database management systems are ruling the roost. Okay, predominantly we use relational databases. We know that for bibliographic data, RDBMS is somewhat inefficient, but we did not have an alternative. Now, but again, the problem with RDBMS, it doesn't scale to the requirements of big data. That is the reason people came out with the alternative database models, which I would just briefly tell. So challenges include capture, curation, searching, sharing, storage, transfer, analytics, visualization, all these. And again, of course, there are constant worry about privacy and security. Okay, so this is common. Whatever be the technology, we are worried about privacy and security. Now, what are the aspects of big data? One is data capture. That means in what format you want to put the data, okay, or structure of the data. If you follow standards, of course, it can ensure interoperability. And if you assign metadata to the data, it becomes discoverable on the net. Okay. Then filtering and weeding out irrelevant data. This is always I feel weeding out is a huge task. Okay. For example, you know, in my student days, everybody was talking how to weed out the books which are no more relevant. The problem is, how do you decide what is relevant and what is not relevant sitting in some kind of environment? After deleting down 10 years, you should not feel, oh, that book was very important or that data was important, but unfortunately I have deleted and there is no way of recovering. That means I have to redo. So I always feel this weeding out is a very tricky affair. Okay, of course it is true that, for example, if you go to any library, probably old libraries, you may see books on database, then WordStar, those old software, or DBase 3, something like that. We do not know. Maybe they may not ever be revived because much more improvements came. But in humanities, whatever Socrates or Plato told, still I think people keep on doing research. Anyhow, so data curation, ensuring long-term preservation and reuse. See, why we are talking about data is reusability. I think this reusable concept came from open source software movement. After that, you know, people started talking about object-oriented programming. So one of the important characteristics of object-oriented programming is how to make your program reusable. That is the reason nowadays, if you use Java or Python or any language, or Perl for that matter, there is a lot of code which somebody can just, instead of writing that code, just pull it and put it in your this one. For example, recently I need to develop programs in Python for web scraping. And then I found already 2-3 packages are there. Then another time, even last month, I wanted to pull out the publications of a particular university from Scopus. Luckily, they have Scopus API. Then we could write Python, and I could see there are already 2 packages in retrieving data from Scopus. Okay, so that's why reusability is very important. Okay, then technology. Of course, now everybody was talking Hadoop ecosystem and NoSQL databases. Of late, Hadoop is taking a little backseat. They put it on the back burner, not quite as popular as a decade back. Then data analytics. These are statisticians. Okay, that is, you know that we are familiar with the descriptive statistics, whether we can go ahead with predictive and prescriptive statistics. So who are the players, and where do we come into picture? So I believe the first thing is, of course, domain experts to begin with, and to the end, they generate data and they consume data. In between, I think there are three more players. One is the library and information science people. That is how to make the data analytics ready. This is the word I coined. Okay, because we collect the data and we curate. That means deduplication, removing any missing values, then normalization of values in the data. For example, if data is collected by various people, in some columns somebody mentioned miles, in another column it is kilometers. Then how to bring a kind of uniformity? That is how do you normalize? So we know that when it comes to measurements, so pounds, kgs, like that, then how do you normalize? Another also is, in some of these data cleaning software, like we used extensively Open Refine in training the Institute of Corporate Affairs people. But again, you can use the powerful package R or Python also. There are many packages in Python for data cleaning. So that is, and publishing the data. Of course, publishing involves many other things, which I will cover a little later. Then computer science people, okay, they configure clusters of computers. That is, nowadays, see, you know that right from 80s, I have been hearing that people want to bring parallel processing, supercomputers, and all that. Nowadays, nobody talks about supercomputers. In India, only Indian Meteorological Department has a supercomputer, Cray XMP14. But nowadays, I don't think anybody would go for that. Even CDAC, for example, Param, like that. But nowadays, the technology is bring out parallel processing by clusters of computers. For example, Yahoo, for its search engine, it uses about 4,500 computers cluster. Then one master computer, then other slaves computer. In DRTC, I configured a 3-server cluster, of course, using Hadoop. Okay. Then anyhow, and NoSQL, I will come to it, what exactly NoSQL is. Then statistics, analytics, and visualization. Okay. Because, for example, for the administrators or others, probably visualization is much more understandable. So how you take the data and visually projecting. In fact, I saw a demo.
Sir, we are already there, Sonali, sir.
I don't know what happened. Host has removed you from the meeting. It came, no? Could you hear me?
Yeah, sir, we can hear you. We can hear you. Please.
Okay, then fine. Okay.
Yeah.
So then domain experts, of course, they are the people finally use the data and they generate the data. So that means library science, computer science, statisticians, they play a second fiddle to the domain expert. So don't think that computer people have a magic wand and do everything under the sun. That is not the case. They always play a supporting role, just as we do also the supporting role for entire research. Okay, now, so NoSQL databases, of course, I am briefly mentioning some of the software also. Probably you might have heard something like MongoDB and other things you might have heard. There is a key value based. One thing, first time when I was learning this, I thought, hey, how can a database be like this? Because we were told that database, each file has a set of records, similar records. And we know first we do data dictionary definition. Here nothing. One record can have 2 fields, another record 200 fields. Okay, this is really strange. Then column-based document, which I think MongoDB is fairly well known. But actually, we worked more on AllegoGraph and Neo4j for the simple reason it expresses the relations. Okay, it allows okay, a simple example I tell you. You might have heard ontologies. But again, we know that library and information science people have been dabbling with the thesaurus, okay, which is a vocabulary control device. And we know BTNT, that is the broader term, narrower term relation. But and we have related terms also, use and used for relation. All these relations are there. Only thing what is missing in thesaurus is we never made what kind of relation it is. Okay, for example, NTBT, you can get entities by genus species relation or whole part relation. But in thesaurus, we just dump them as all our entities. Okay, are related terms. We simply say gold, then ornament, mining, like that. But we don't tell an ornament made of gold, made of silver, like that. Those relations, if we make explicit, then you can build inference engines, which is essential in semantic web technology. So in semantic web technology, also librarians have a very great role to play because it is mostly metadata and ontologies, building relations. Okay, that's why I think when I conducted sometime in 2007 on semantic web technology, the European semantics technology computer science people wrote a nasty letter to me, as if I am a conference organizer to spin money out of it. And nowadays anybody can organize a conference on any subject. That is true. I can conduct a conference on analytical chemistry without knowing what it is. But again, I explained about 2-3 pages in which way librarians play a very great role. And they were convinced. 12 of them attended my seminar. Later, they asked me, "Can you send somebody to teach library classification in our computer science department?" Then, Dr. Devika took 1 semester classes there and came back. Okay. So after that, we proposed a project. That is why you have seen that living project, living knowledge is more on the semantic technology using faceted classification systems. Anyhow, this AlgoGraph and Neo4j are more promising because they deal with graph databases. Okay, what is descriptive analytics? Okay, the simplest class of analytics. Purpose is to summarize what happened. As big data is not suitable for human consumption, descriptive analytics allows you to condense big data into smaller, more useful nuggets of information. Okay, this I think goes with we know that much of the library science research is based on usage or user studies. And I think everybody must be using some kind of descriptive analytics. Then predictive, it uses various statistical modeling, data mining, machine learning, all these, okay, and try to forecast, okay, what will happen. But you have to accept this is probabilistic in nature, okay. See, after all, the statisticians are predictive analytics based statisticians are not astrologers, no. Okay, astrologers have the power of predicting the future, or at least bluffing the people and predict the future. But whereas statisticians don't do that, okay. They tell, this is probable, okay. And fuzzy sets and all these, because life is very, very complex. That's why I always say, I belong to Indian Statistical Institute. My favorite job is to pull their leg. I used to say, hey, when you are talking about probability, it is not an exact science. It is only an approximate science. Okay, it is nearer to the science because probability. Okay, then they say no, it's a science of approximations. Okay, then prescriptive analytics. Okay, that is assuming, for example, I have the data on terrorist attacks, whether I can predict what could be the next place and time, whether there is a pattern in their attacks, and could predict. If I could predict, or at least chances, if there are more than one place or anything, how do you counter that? So this is prescriptive analytics. Okay. Now I come back again. Okay, this is my favorite area, open access to information. I believe almost 2 decades, a fairly successful movement. Then there are open access repositories in Open Door and other things, more than 2,600. Then you have more than 10,000 now, much more than I think 13 or 14,000 on DOAJ. Partially bridging the digital divide in social, physical, and natural sciences and humanities, but not completely in physical and natural sciences. That I will come, where data bridges a better, it bridges the divide better than the just open access to information. So nature of publications, many publications use data. Okay, actual article may not have complete data used. For lack of space, author might not have overlooked the data, author deliberately did not present the data so that others cannot verify the data. After all, we are part of the society, okay? We inherit the dark side of it also. You know, the greatest, I mean, my favorite scientist, Sigmund Freud. Many, you know, in psychology, whenever they publish, they keep the subject name, anonymize it. Okay. Actually, in data analytics also, if it is medical data, we try to data so that nobody knows about which patient it is. Okay. So some people say not only fictitious names, the entire stories which he has written. I read his interpretation of dreams. Is who knows? Okay. In any case, if data is available, others may draw different conclusions contradictory to that of the author. But sometimes they may deal with other facet of the data. In the sense, say for example, if data, census data is there, somebody may look about how education is distributed among the various states. Then otherwise, they can come out with a correlation whether women and education and development in terms of GDP and others are there. So you can do many facets. So data also has many facets. Okay, that you can study. Data transparency supplements the objectivity and self-correctiveness of the science. You know, what is science? Okay, one of the characteristics of science is objectivity. That means whether X does the experiment, Y does the experiment, or Z does the experiment, one should get the result. That is not the case with religion. No, if somebody religious Baba says, I have seen the God, but if you say, I want to, I also, please show me, yeah, they cannot. Okay, that is where we feel much of the religious experiences are subjective, if not untrue. Okay, some case history of patient, if it is openly available, our medical research will, I think, takes leaps and bounds. But you know that hospitals, if they administer one course of drugs, if the patient dies, they won't tell that because their business will go down. Or if they are successful also, they won't tell because they want to increase their business. Okay, so open data. You know, one of the biggest success stories is human genome data. And now it is, I think recently again they published, I think sometime in 2005, I think they completed the work, but I think now second round they went. And the data from accelerator labs, okay, you know that Higgs Bosonian God particle and other people are talking about. Recent controversy about a particle moving faster than light. This, you know, about 5-6 years back, some Italian scientist claimed he found a particle that moves faster than light. Naturally, it hit the headlines because it makes the entire Einstein theory, nothing can move faster than light, topsy-turvy completely. So everybody jumped at his data, okay, and found the data is wrong, his interpretations are wrong. Actually, in one of my projects, the computer science people are from that INFN lab of Italy. I asked my colleagues in the project, what happened to that scientist, obviously physicist. No, he was asked to resign. So that way, we believe science has a self-corrective mechanism in addition to objectivity. So again, once I was asked to address the Vision 2020 of European projects, So I was telling the astronomy peculiar subject. People have been sharing astronomy data for I think centuries, okay, or decades, at least decades. I thought, see, I am a crook in my own way. Then I thought, how on earth the people are sharing the data? Then I told the audience, probably still we don't have territorial claims on the universe. Once those claims start, now I want to occupy Mars, some country, okay, then they won't reveal any data about astronomy and astrophysics. Okay, so anyhow, now, features of open data repositories. You should have metadata for every data set so that discoverability is ensured. Then you should have license. You know that licensing is always a tricky affair. Everybody will have a lot of copyright issues and other things. But if you want to have a good sleep without worrying about whether you violated a copyright or not, I think licenses should be in place. Then technology tools, okay, automate data extraction, ontologies, indexing the data. Okay, you know, there are many licenses. That is, my favorite is CC0. Okay, that is no restrictions on reuse. Whether somebody wants to use commercial, okay, let it be. Somebody from so and so country, let it be. He did not acknowledge me that he borrowed the data from me. No, don't worry. Okay, that is my approach. I think why I have to keep everything close to my chest. Okay, that is the idea. That's why there are so many other data licenses, but my favorite is Creative Commons CC0. Of course, Creative Commons comes in various flavors. So data repositories by various governments. You know, actually government data, not only research data. Now I was talking thus far about the research data, agricultural data, or chemistry data, or anthropology data, or sociology data, like that. But even governments are publishing data. You know, data.gov.in, which has more agricultural data than anything else. So we believe in the West, if you see, even city level data sites are there. That is, unique city level data is there. The advantage in that is, I always feel, if the, see, for example, we know that there is a program called Smart Cities in India. But in my hometown, I find some roads were widened with pavements, and some speakers here and there were fixed to announce whether the flood, because it's a coastal, this one warning, any cyclonic warnings are there. But I feel smart city is different in the sense, if I have data about every aspect of city administration, of that municipal administration, that is how much garbage is being generated, how many garbage recycling plants are there next 10 years, how many more we require, how much traffic, how many vehicles are being registered, and how many vehicles are entering the city, then how many accidents, traffic jams. If we have this data, we can build a powerful decision support system. That's why I have been advocating smart cities can only be realized when we have data about everything. Okay, it should be based on data and data-driven decision support system. Okay, until then, otherwise it will be like this. You know, in the earlier government launched the National Knowledge Commission. Of course, I was on the library group, but there is another group called NKN, National Knowledge Network. And finally, what I found is they gave internet connectivity to various universities and research labs. But where is the knowledge on that network? Just connecting, is anybody, now we can do, even Jio can do, or Airtel can do, or any vendor can do the physical connectivity. But that is not, I see as a knowledge network. Okay, I think we are missing the knowledge on the network. So is the case with the smartness in the city administration. Okay, one of the best, I think, the Australian administration. There are data repositories. Okay, just as a directory of data repositories, just as we have open door, no, for open access repositories, whether DSpace or ePrints or whatever they were using. Then you have earlier, of course, data bib like that. Now it is RE3 data, okay, and you can access that. Now I think the registry entries provide URL of the data repository, also brief description of it. Manually, one has to visit and download the data from data repository. But in future, I am sure some of them are giving already APIs so that you can write programs to extract the data from those. Now, what is the role of a librarian? Okay, so facilitating data reusability, because we are talking about, see, if the data is being reused, for example, human genome data, okay, now it is openly available. That means I have to find out patterns in the gene sequences. Perhaps I may be using a lot of mathematical formulas. So, but again, I cannot generate the entire genome patterns and to find out, okay, which pattern reflects the fairness of the skin, or which pattern reflects, okay, this a normal gene should be like that, a cancerous one should be like this. So that, if it is downloadable, even if you are in Timbuktu, still you can do and participate in Human Genome Project. That is the greatness of reusability of the data and openness of the data. Okay, so data reusability and interoperability, discoverability, these are all our jobs, following some standards, protocols, and all that. Okay, so data curation, collecting verifiable digital assets. Okay, that is data sets. Providing digital assets, search and retrieval mechanism. That I think for us a beaten track. That is, we add metadata to it. Then certification of worthiness and integrity of the collection and the content. Of course, we try to ensure, okay, this is clean and to the best of our knowledge, this is trustworthy. Sometimes the data can be flawed. I mean, there are many intricacies in that. Then semantic and ontological continuity, okay. Then use of open standards. We always say open standards play two important roles. One is interoperability. That means it becomes platform independent, okay. Just as a browser, you see, in a browser you enter some key in Google. Do you know which system you are accessing? What is the operating system? I have no clue. But you can see the images, movies from that site without knowing what is the hardware, what is the operating system, what are the search facilities. Nothing. It is all transparent. That interoperability is ensured by browser. That is the reason good old days, library automation packages, they used to give GUI. Later, now we say, no, is it browsable, browser access, browser-based software, so that anybody can access from any other system. And another thing with open standards is long-term preservation. That means, that I think I helped one of my methodology friends for his thesis. I used Curation those days. Okay, because my own thesis I used tech, but Curation, because mathematical formulas and all that, that was a easy PC based one. Those days tech was not available on PCs. Then now he has his thesis in Curation, but Curation software is not around. Okay, at least if the format is an open format like the ODP, if you use LibreOffice or OpenOffice, they give open formats. To ODP is for presentations, ODT for Word files and other, writer and other things, so that as it is an open standard, even tomorrow LibreOffice is dead, still I can sit with the programmer, say, these are the specs. All the images are nothing but compression algorithms. So if those compression algorithms are published, which is the case with open standards, even if that image in some old format and no software is opening it, still the programmer can look at and develop a program to decompress the image and see it. So that's why we discourage people not to use proprietary standards, because as it is, nothing is permanent, and these proprietary ones, we don't know whether that how long that format would be popular, or even the company may wind up. Big companies like DEC and others, they disappeared, because those are wonderful companies with fantastic R&D, but they are not there. So because that is the importance of open standards. Okay, so again we have, of course, basically I am giving some ontology frameworks. We have resource description framework, or SCAS, and A.R.D, another language. Okay, then we have done a lot of projects. Okay, I mean, the living knowledge, of course, this is about semantic web using Ranganathan's this one and Bhattacharya's POPSI. Then, of course, under this project, we have an MOU with one Italian university. AgInfra is agricultural data. European projects, consortia of universities proposed 10 to 12 universities together. That time, India was an associate member, so we could get 2 projects. Of course, in AgInfra, the UNFAO, Chinese Academy of Agricultural Sciences, all these guys were there. Okay, these were, I think we conducted a lot of international workshops with co-data people. Then one of my colleagues is a member of RDA Research Data Alliance, a technical advisory board member and other things. Okay, so this is, of course, some of the universities are moving to incorporate data science related topics. I don't claim that in DRTC we teach data science, but again, we teach data management. And in the industry, when I invited people from IBM and other places, they were telling data cleaning occupies 70% of the work, 30% only analytics side. That means we have a very big role to play in data cleaning. Okay, so conclusion, researchers do generate data from experiments and surveys. Researchers may use already existing data for further analytics and interpretation. They may not publish the entire data generated and collected, which we say dark data. Okay, long back when I was giving consultancy to a newspaper, I wanted to see what is the vocabulary control here. Then I found some German guys developed. I wrote to them, oh, that data, we junked it, we don't know where, in which system it is. See, this is the problem with academicians. Once their project is over, or once they publish a paper out of it, they lose interest in preserving the data. Now, at least, there is an opportunity to publish the data using data repository software. Actually, we conducted, there are 2 popular software, which I did not cover, I think, in this, because I reached the conclusion. One is CCAM, which is mostly used for government data, but I find it can also be used for science data also. And there is a Dataverse from Harvard, if my memory is correct. We conducted, in fact, we invited them on online presentation on Dataverse also. Okay, these 2 are the most popular ones that are being used by various repositories. In fact, I think maybe, in fact, I am trying to work out whether just as we popularized DSpace, whether I should do an all India campaign popularizing the data repository concept, how to clean the data and make it analytics ready, and how to publish the data, and with various licenses, metadata, blah, 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 everything like that. Okay, thank you.